All right, so today we're going to talk about more verifying with trig identities, and we're going to solve some equations too. All right, so we need to take our guided notes. And I like to take some identities from your book because in calculus, believe it or not, these trig identities are going to be your best friend, especially when you're trying to integrate something. And when we get to that in maybe calculus next year, I'll say, remember when I said these identities were going to be your best friend? You'll go, oh yeah, I remember that. Well, here it is. Now, I'm going to challenge you guys to use, when we verify these identities, to use the left side here. Because right away, I think you can see what you can do with the right side. You can make this into cosine squared x, and then you get a cube. But the problem you're going to get in calculus is that you're going to get the integral of cosine cubed x, and you have to transform it to look like this in order to work with it. Okay, so we're going to use the left side here. Well, what do I have to do? Well, what I want you to notice is what do you have hanging out here all by itself on the right? It's a cosine. So I am going to break this cosine cubed up into cosine squared x times cosine x. Good. And then to make it look like the right side, I have to make one more substitution. And what's that going to be? What does cosine squared equal?
1 minus sine squared x.
That's right. 1 minus sine squared x times cosine x. And we're done verifying that. So it wasn't as difficult as it looked, even though your instinct would be to use the right side instead of the left side. Okay. And we'll call this a, no, it's a pow. All right, so let's do the next one. Again, I'm going to challenge you here to use the left side. And what you have standing all alone here on the far right side is a secant squared. So that's going to be your clue to separate out on the left. You're going to say secant squared x times secant squared x equals, and then using our Pythagorean identity, we're going to say, well, secant squared equals 1 plus, yep, 1 plus tan squared x times secant squared x. And believe it or not, this is the only way that you're going to be able to integrate secant to the fourth x when you get to calculus, is to break it down like this. And then we'll be using something like u substitution to integrate that, okay? Okay, challenge you again here. Because the right side, what would you do? You would factor, the trinomial here on the right. But I'm going to challenge you. So let's expand the left side to match the right. What do we have? Solo over here. A sine x. So I'm going to make this
Sine x.
sine to the fourth x, sine x. Now what could I do? Yep, Taylor.
You can make the sine to the 4x 1 minus cosine squared x.
Can we? You're right. You're absolutely right. Can we have a step right before that? What did you do in your mind, which was right? Can I change it to sine squared first, and then make that step?
Yeah.
Yes. So you're on the right path. I just want to show this step first.
On the quiz, when we get to the
Yeah, I need to see. I need to see those steps.
Okay.
Yeah. You need to show me as many steps as you can. Just, I don't want to have to say, well, I know Taylor did this. You know what I mean? Mm-hmm. Okay, so and then you said, well, then I want to multiply. I want to change sine squared x to, using the Pythagorean identity, 1 minus cosine squared x times 1 minus cosine squared x times sine x. And I'm getting even closer now to the right side. And then what only thing I have to do now is distribute, don't I? And we're going to get the same thing as the right side. So this would be 1 minus 2 cosine squared x plus cosine to the 4th x all times sine x. And that gives you the right side. Oops. Oh, I forgot my check mark. Yep, now,
Oh, for like a specific, or for a quiz, would you like tell us to use like a specific side? Like
no, I mean, if I wanted you to say, I would say start with the right side or whatever, but on this quiz, on Friday, I'm not going to tell you which side. You can choose whatever side you want. I'm just doing this as an illustration. Okay, we should call this a what? A boom. I heard a boom. I'm trying to think of, the things that the Roadrunner and Batman and the
Like, wow.
kaboom and all right. Anyway, so keep thinking. All right, moving along. We're going to expand the left side again. What's standing all by itself?
Cosine.
A cosine. So we're going to bust this up into a sine squared x. Cosine to the 4th x times cosine x. And then what do you think we're going to do with that cosine to the 4th? Split it up again. Yeah, so that will be sine squared x, cosine squared x, cosine squared x, times, cosine x. And then we're going to change the cosine squareds to 1 minus sine squared x. Yep, so this is sine squared x times 1 minus sine squared x times 1 minus sine squared x times cosine x. And then multiply out the middle part, so we get sine squared x times 1 minus 2 sine squared x plus sine to the 4th x times cosine x. And then one last step. What are we going to do last? Distribute that sine squared. You're right. So it would be sine squared x minus 2 sine to the 4th x plus sine to the 6th x all times cosine x. Lots of writing. And we have proven it. What are we going to do?
Yeah.
Poof? Like we stumbled into it or what?
Something.
Okay, here we go. All right. So that's the quick of the review of verifying. And now we're going to solve some equations. Well, so far when we've been solving these quadratics, what have they done? We've been able to factor them. Are all quadratics factorable? No. So what other way can we solve a quadratic? We use a quadratic formula. Somebody said complete the square yesterday. Now I wouldn't want to do that with these. Do you want to?
No.
No. All right. Okay, now that was a big no. All right, so let's review or recall. When do we use the quadratic formula? We use it when we have ax squared plus bx plus c equals 0. And the solution to this equation would be x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac
all over 2a.
all over 2a. And I like this busted apart because that 2a belongs to both expressions. And if they're apart, then you don't get them wrong. But in this case, I have this situation, a cosine squared x plus b, I'm going to put plus b cosine x plus c equals 0. So what's the variation going to be? Here I said x equals, here I'm going to say cosine x equals. Cosine x equals the opposite of b over 2a plus or minus the square root of b squared minus 4ac all over 2a. So that's the only difference. Is you're going to take your trig function and say it is equal to the quadratic formula equation there on the right. Okay, so it looks a little awkward, but it works out very well. And in fact, I have a lot of people that will prefer to do the quadratic formula instead of factoring. And it doesn't matter to me, but I choose like the factor if I can. I feel like I'm quicker at that. All right, what is a in this case? 1. B is -1, and c is -1. And so I'm going to say then cosine of x equals 1 over 2 plus or minus the square root of, well, -1 squared is 1 minus 4 times 1 times -1 all over 2. So we're going to get cosine x equals 1/2 plus or minus the square root of 5 over 2. Okay, so I have two solutions there. I can say that the cosine of x is equal to 1/2 plus root 5 over 2. Or the cosine is equal to 1/2 minus root 5 over 2. Now, clearly, 1/2 plus root 5 over 2 is not one of the standard values we know in the unit circle, is it? So let's do a little bit of analysis here. 1/2 plus, well, what is root 5? Slightly more than 2, because the square root of 4 is 2. So root 5 is slightly more than 2. What kind of number is this? This is going to be slightly bigger than 1. So this is 1/2 plus 1, and that's greater than 1. Now, what do we know about the cosine function?
It cannot be greater.
It can't be,
Greater or less than 1.
right, it can't be bigger than 1 for sure. So I know that this one has no solution. This can never be. Since the cosine of x has to lie between -1 and 1 inclusively. And do I need this since with your explanation? The answer is yes. I'm reinforcing, right? What you know. Yes, sir.
Well, I was just gonna ask, is since required, or can it be like because?
It can be because. I'm all right with because. What about this one? Cosine x. Ooh, wow, it does the whole line. I don't really want to do the whole line, but cosine x equals 1/2 minus root 5 over 2. Let's think about what kind of number that is. That's 1/2 minus something just a little bit bigger than 1. Is that going to be in this interval, -1 to 1?
Yes.
It will be. So, and what kind of number will that be? It's a negative number. So what quadrants is the cosine negative? 2 and 3? Good. So I'm going to have an x1 solution and an x2 solution. And I am in radians up here. Do you notice that the solution set said I want 1 time around in radians? Okay, well, now I need to find alpha because that's certainly not one I know. Now we said, didn't we, that that was a, what kind of number?
Negative.
Negative number. All right, so let's get our calculator out. We need to be in radian mode. You get calculator? Uh-huh. I don't know what mode it's in. As we watch the TI advertisement here. There's our calculator. And I'm going to go to y equals, clear this out. Clear this out. And we're going to go second quit and see what mode I'm in. What mode am I in here? Radians. Yay, that's good. All right. So I know that's a negative number. And if I wasn't sure, I'm going to go alpha F1 and choose this number. What is it going to be? 1/2 plus or minus, right? Square root. I'm going to do the alpha F1 again and do my fraction. Second square root of 5/2. And let's just verify for a minute that that's a negative number, is it? Everybody got that as a negative number? I'm going to store that in alpha A. Am I going to store a negative number in alpha A or a positive number in alpha A? We should store the positive. Now that's a negative number. So what I'm going to suggest to you is you say negative second answer. Right? So that says take the answer and make it the opposite. And then we hit the store button and go alpha A. Press enter. And there it is. There's the positive. And now we want to do the inverse. Cosine of alpha A.
How do you do that?
How do I do what?
The answer arrow.
Okay, so I just went. See, the answer button is the answer. The blue button on the
And where's the arrow?
the second answer. Do you see ANS here? Or you could go negative parentheses and go and grab that if you wanted. Okay. All right. Did you get 0.90455?
Yes.
Okay. And I'm going to stow that in alpha B. I'm going to put that in B. And then I'm going to take my screen over here and put it here. Make it a little bit smaller. So what did I do? I went negative of 1/2 minus root 5/2, didn't I? Is that what I put in the calculator? So what is alpha approximately?
0.9.
Approximately 0.905. I'll just say 0.905 roughly. Now, I don't need alpha, I need x1. So, and this is pi if I'm in radians. So x1 is going to be pi. I didn't go all the way to pi, I'm alpha short. So it'll be pi minus alpha. And x2 is going to be, I went pi and then I went alpha more. So this would be pi plus alpha. And so when we do that math, anybody come up with some numbers for me?
2.23.
2.23, 4.05. And those would be your two answers. Questions on how to do that? So this would be on a calculator section. And let's say you didn't know this was a negative number. Could you check it out and see that it was a negative number? Yes, sir.
How do you do the fraction?
You go alpha F1. That's an amazing thing. You choose numerator or denominator. Yeah. Okay. All right, so we can do another one? We shall. All right, this one factors, or we can use the quadratic formula. Which would you prefer? Okay. You'll get the same answer either way. Doesn't matter. let's say you chose the quadratic formula and it factors. What's going to happen is your discriminant will be a perfect square. Now that's a big word, discriminant. B squared minus 4AC will be a perfect square. Let's see if that works here. I'm just going to write this on the side just to have a discussion. Self-discriminant, I hope that's right. What is that? It's B squared minus 4AC. So in this case, it's going to be 16 minus 4 times 3 times negative 4. So that's going to be 16, looks like plus 48, which is 64. Is that a perfect square? Guess what? That means this will factor. So yeah, let's factor it. I'm all right with that. So 3 tangent squared x. So 3 is prime. So my only choices are 3 tan and tan. Now I have a choice with 4. Whoops. I have a choice with 4. I can say 2 and 2, or I got to get a 4 in the middle. And they have to be opposite signs here. So I think 2 and 2, because this is going to be a 6 tan and a 2 tan. Will that give me a 4 if I add them together somehow? And what has to be positive? The 6. So this is going to be plus and this will be negative. All right, so now I have 2 solutions here. I have 3 tangent x minus 2 equals 0, or I have the tangent of x plus 2 equals 0. So let's do this first one. We get 3 tan x equals 2. Tan x equals 2 over 3. And then I say, okay, well, what quadrants is the tangent positive? 1 and 3, good. So I have an x1 and an x2 situation, and alpha is one I don't know. So we're going to go inverse tangent of 2/3. I don't have to worry about the danger here because, clear this out, that's a positive number. So we can say second inverse tangent of 2 divided by 3, and we get a number. We get a number, and then I get a number.
0.58.
Great. Love those. Okay. And then I'm going to store this in alpha A. All right. I'm going to bring this down here. Maybe I'll bring it down here. There we go. Make it smaller for us to all see. All right, my first solution, which is really nice, is equal to alpha, isn't it? Because it's the first quadrant solution. And we get 0.588. X2 is a third quadrant solution, so I went pi and alpha more. So this would be pi plus alpha. And that turns out to be, what is it?
3.7.
About 3.73, thank you. And so that's the first set of solutions. And then I have to solve tan x plus 2 equals 0. So let's do that over here. So tan x plus 2 equals 0. Tan x equals negative 2. So tangent's negative in quadrants. 2 and 4. Good. So alpha is one I don't know, and danger, danger. Well, Robinson, this is I have to do it over positive. Yes, I know. I date myself every time I say it. Okay. Let's see, inverse tan of 2. 1.01.
1.10.
1.
So just 1.1.
1.11. And then x1 is going to be the second quadrant angle. And if this is pi, I didn't go quite pi. I'm pi, alpha short. So this is pi minus alpha. And that's approximately 2 point what? of 3. And then x2 is equal to, I didn't go all the way around, I'm alpha short, so that's going to be 2 pi minus alpha, 5.18. There you go. Now, am I okay with the fact that this is labeled out x1 and x2? Maybe I should make this x3 and x4, because I have 1 and 2 over here. Yes, sir.
On like a quiz or something, would you want us to write pi minus?
Yes, I would love that, because what happens if you put this wrong in the calculator and you get the wrong answer here? But you showed me you knew that it was pi minus alpha. I can give you credit for this and take a quarter point off, because this is showing you know how to do the thought process, which is really important. Okay, yeah. So showing you that makes me very happy, along with showing me the
Perfect chart.
reference triangle that you hate to do. I know, but not all of you, but some of you. Okay, keep going. Uh-oh. Now, in order to use the quadratic formula or to factor, they all have to be the same trig function. Well, guess what? They're not in this case, and it's not even set equal to 0. There's no such thing as the 3 product property anywhere. It's just the 0 product property. The 0 is a big deal, as Mr. Johnson always says. 0. Right, that's a big deal. He doesn't go 3, does he? No, he just goes 0. So it's the 0 product property. So the first thing I'm going to do is set it equal to this equation equal to 0. This is secant squared x plus tangent x minus 3 equals 0. Now, we can't change tangent into anything with a secant, but we can, with the secant squared, we can use the Pythagorean identity for secant squared and make it into a tangent expression. What is secant squared equal?
1 plus 10.
That's right. So this is the deal. We have to change this to 1 plus tangent squared x. And yes, sir.
Equals sine.
Yes, you could. And then make this 1 over cosine squared x and find a common denominator, all of that. And have a double-decker fraction? Yes. You sure, absolutely, Justin. You could absolutely do that. There's nothing wrong with that except that it takes you a lot longer to do. Okay? So I would strongly encourage this step here. Okay? Great question. All right, so this would be 1 plus tangent squared x plus tan x minus 3 equals 0. And then I'm going to put things, add like terms together here. We get tan squared x plus tan x minus 2 equals 0. Now we can use the quadratic formula here, or I think this one indeed factors. So which would you prefer? Okay. So we're going to say then tangent and tangent. And then the factors are 2 and 1, and we have to decide which one's positive and which one's negative because this last term's negative. It's going to be what? Positive 2 and negative 1. All right, so then we're going to get tangent of x plus 2 equals 0. And then we're going to get tangent of x minus 1 equals 0. Now, did we just solve this one? If you look back.
Yes.
We did.
Okay, so I'm going to go back here in time, and I'm going to cheat. I know. But technology is so wonderful. And I'm going to put this right here. Because we just did that, didn't we? I'm going to even make it look like it goes there. Look at that. It's as if I wrote it all out again. You can just say, see, previous problem on your paper, right? For your notes, you can say, see, previous problem. I'm sorry I can't copy and paste for you on your paper.
Not yet.
Yeah, I'm gonna make
Not yet, but it's coming. You're right. All right, next one is
Yeah, that's good.
tan x minus 1 equals 0. which means tangent x equals 1. Now, what quadrants is the tangent positive? 1 and 3, good. Now, remarkably, I think this is a tangent value that I know. This is the standard value on unit circle. So what is alpha? Where is the tangent equal to 1?
45 degrees.
Okay, we're in radians, but I heard pi over, I heard 40, I heard them both. So we want the 45-degree radian angle, which is pi over 4, yes. And the good news is x1 is going to be pi over 4, and x2 will be then the third quadrant pi over 4 angle, which is 5 pi over 4, yep. There you go. If it is a standard value that we know, I want the exact solutions. Okay, so no calculator here. If this was tangent x equals root 3, alpha would be pi over 3. Okay? If it was tangent x equals root 3 over 3 would be, alpha would be pi over 6. All right? I know, I'm hurrying here. Everybody, do you need to see it for a minute? Okay. What are we going to do with this one? Move the 2 to the other side. I like it. So this is cosecant squared x minus 4 cotangent x plus 2 equals 0. And we got to get the same trig function here. Yes. This equals cosecant squared x equals 1 plus cotangent squared x. So that's 1 plus cotangent squared x minus 4 cotangent x plus 2 equals 0. And we get cotangent, adding like terms, cotangent x minus 4 cotangent x plus 3 equals 0. Cotangent squared x minus 4 cotangent x plus 3 equals 0. Okay? And this one, factors. So what that means, we have a cotangent and a cotangent. And we have to have the factors of 3 that add to 4. So 3 and 1, and they both have to be negative, yes. All right, so we're going to say the cotangent of x minus 3 equals 0, or the cotangent of x minus 1 equals 0. All right, so I'm going to solve for cotangent x. We get cotangent x equals 3, but I don't know the cotangents. And we don't have a cotangent function on our 84, so I'm going to say that this is going to be, what's its reciprocal? So this will be tangent x equals 1/3. And then we go through the process of stating, okay, tangent is positive in what 2 quadrants? 1 and 3. So alpha is going to be inverse tangent. Don't have to worry about the danger because that's a positive number. And alpha is approximately 0.32
or 0.322.
322. Good. All right. And then lucky for us that x1 is approximately alpha. So it's 3.322. And x2 is going to be
Pi plus alpha.
pi plus alpha. Good. Pi plus alpha, which is approximately 0.46. Can I have one more digit? 3. Okay, good. Nice. All right, good. All right, here we go. We're going to say that this is cotangent of x equals 1, but we're going to reciprocate it. So tangent is 1. That's really nice. We just did this one. No, I can copy from the other page. But let's quadrants 1 and 3. Alpha here is pi over 4. I can do this one quickly enough that by the time I copy it, I'll work it out. Yes, sir.
How did you get tan x? I thought it was 1.
Okay, tangent's reciprocal, this is really 1/1, isn't it? If I take the reciprocal of cotangent and make it tangent, I reciprocate the right side too, and I get 1/1, which is 1. Like I did it here. If I know that cotangent's 3, I know the tangent has to be the reciprocal of 3, right? That's all I'm doing. And then x3 here in this case would be pi/4, and then x4 would be 5pi/4. All right. Now, really quickly, let's go back to the beginning. In the beginning, on the very first page, we had an identity, didn't we? Okay, on the homework sheet, it says for this tonight that I want you to use the Desmos graph and, you verified algebraically, but I want you to verify it graphically. So I'm going to get my driver here, Mr. O'Reilly here. Okay. And let's get you on the right page here. We're going to be this one. No, not that one. This one. I want my apps, and we're going to go over here and hit Desmos. Double click it. Okay. And the identity that we're going to type in is y equals, now cosine, and you can raise that using the caret symbol, okay, I'm going to hop down and then go X and then enter. Oh, it doesn't like that. So let's put parentheses around the X, I think, maybe. No, yeah, right there. Oh, no, it still doesn't like it. Okay, so get rid of the, go back. Let's just keep going. Cosine of X. Delete.
Oh,
That's all right. It's okay, relax. Backspace.
X.
Yep. And then let's put parentheses around the whole thing. Yeah, you know what I mean. You got it. And then let's cube that. Here we go. That's cosine x cubed. All right. And what does the right side say? So we're going to put parentheses. 1 minus. We're going to have to put sine squared in parentheses, right? Because it obviously didn't like that. So we're going to put parentheses sine x. Just x. And then close the parentheses. Caret squared. Close the parentheses. No. Hop down. Yeah, I'm sorry. And then times what? What was it said? Times cosine x. Are they the same?
Yes.
So that's what I want you to do is do your verify and then grab out your Chromebook or your phone because you have the Desmos app on your phone. And we can even show that if I hop on this side, it will, you see how you can see they are identical? The right side is equal to the left side. Graphically as well. Well, I don't want to do that yet, right? Because I want to get rid of that. So we're going to say new. Okay, so that's what the assignment sheet means when I say verify using Desmos. Okay?
Do we write anything down for that?
No, I just want you to do it. Make sure that you know how to do it. Because, on a problem of the week or something, or problem of the day, I'm going to ask you to do that, okay? All right, so that, my friends, is the end of our show.